Good afternoon. My name is Dylan Beattie, and my talk today is about happy code. It is life, liberty, and the pursuit of APIness. A little bit about me. This is me. I've been building websites since 1992, so kind of ancient history as far as web application development is concerned. I'm a Microsoft MVP with the Visual Studio and developer tools. I run the .NET user group in London, where I live. My website and Twitter address and everything are here. So if you want to talk about any of this stuff or anything I work on, find me on Twitter. Find me online. Drop me an email. It's always nice, chatting to people and exchanging ideas and stuff. Now, я не говорю по-русски. I don't speak Russian. So when I heard I was going to be coming back, I was at St. Petersburg in May when they said, do you want to come back to Moscow? I thought maybe I would try and learn a little bit. So I found this, Duolingo. Did anyone use this to learn languages? It's very good, but it taught me some Russian that is not very useful for doing technical talks. So I can say, я девушка, а ты? Как вы знаете, мой брат не умеет читать? And this one got me in some trouble. Moja девочка не умеет готовить, зато он много ест. So maybe next time, but today I will speak to you in English. I speak English. I tend to talk quite fast, so if you miss something and you want me to just go back and repeat, just hold up your hand and wave like this, and I'll just go back and run it again. Yeah. If you keep doing that, we'll get everyone doing it. So yeah, I'm going to talk to you about this idea of happy code. Now, the company that I've worked for in London for the last 15 years is a company called Spotlight, we're in show business, acting and television and films and these kinds of things. And in show business, we have this sort of default clip art that everybody uses, which is these Greek theater masks. They're called comedy and tragedy, happiness and sadness. And something that I have noticed in the course of my career as a developer, I've seen projects that should have been successful. It was good team, interesting problem, good technology and everything, and they failed. And, 3 months later, you go into the office in the morning and everyone's just like, oh. And you do a stand-up, like, what did you do? They're like, I have this problem and this doesn't work and that doesn't work. And I've also worked on some projects where it starts out and you're like, this is crazy. There's two of us, we have no money, this problem is impossible. And 3 months later, you're like, this is really cool. This is awesome. We've solved that problem, and we worked out how to automate the deployments, and we worked out all these different things. And I think there's a lot to be said. The team who are not happy, the team who they don't want to go to work and they're getting worn down, they're sad, they're miserable. These teams don't ship good software. And the teams who are happy, I think, tend to ship good stuff. I can't think of any example I've come across where people who do not enjoy their work are still actually producing good systems. And so I started thinking maybe there's something to this. Maybe I can, look into it, do some investigation, find out more about how other things we can do to make teams happy. And, I'm not talking about buying like a foosball table and, office games and stuff. Most developers enjoy coding. That's why we do it. We do this because we sat down once with a computer and went, this is cool. And we're very lucky, many of us, that this is now what we do for a living. But I wondered if there were some ideas we could build on to sort of extend that. Now, there's a couple of things I'm going to talk about in the first part of the talk today. One of them is something called discoverability. Discoverability it's the ability for you to explore a system and find out how it works for yourself. So you can try things. It's safe to explore. There's a sandbox, so you're not frightened to touch it. It's a system that kind of encourages you to play with it and try and almost solve it like a game, like a puzzle. And the reason I think this is important, one is because it means you don't need things like documentation and training manuals if you have systems that are discoverable. But the other thing, there's research they've done about, you ever been you're fixing a bug, you're at work or you're working on one of your projects, and you just you basically work all night. You fix something, you're like, that was cool. And then you're like, oh, another problem. Yeah, I'll just fix that one. I'll just fix that one. And then it's like 3 o'clock in the morning. And you've been working all night because you just keep getting, it's like playing Super Mario. You're like, I just have one more go. Now, there is actually a chemical, a neurotransmitter in the human brain, which is called dopamine. And when you solve a problem, when you solve a puzzle, you get this burst of dopamine in your brain. It's the same thing that gamblers get when they win. It's the same thing that drug addicts get when they take drugs. But you also get it when you solve problems. And the interesting thing about this is that when you're experiencing this, you actually learn better. You learn things more quickly, you remember them for longer, and it's quicker for you to then take the thing you've learned and applied it. So if we can build systems where the person who is working on our code feels like they're solving puzzles and learning things and they're getting this little dopamine buzz in their brain, they're going to get productive quickly, very, very quickly on the systems that we're building. We have these things in educational psychology. They talk about the idea of a learning curve. Now, a learning curve, I got 2 examples here. Basically, this is just a measurement of how much time have you spent working with a system, and how good are you, how competent are you at working with that platform, that technology. Now, we have 2 here. We have a blue one, which is what we call a very steep learning curve, and we have a red one, which is a shallow learning curve. But raise your hand if you think the blue curve is better. Raise your hand if you think the red curve is better. See, I always do this. It's always about half and half. Now, some people prefer a kind of slower process. Some people prefer a steep process. Lots of people say a steep learning curve is a bad thing because it's hard. But if you work hard, you can do really cool things. So the blue curve here, this is someone who learned Haskell in 24 hours. They went home and they did it. The other one is that person in your office who they've been using Microsoft Word for their whole life and they still don't know how to do a page break because they all this time and they haven't learned anything because it's easy, you know. They're both good, you know. What we want to watch out for, so one of the things that you really want to avoid when you create systems that new users are going to use is something we call a localized peak. So a localized peak is when they've learned a whole bunch of things and then they suddenly realize that everything they've learned is wrong and they need to go back and they need to start again. Anyone do ASP.NET web forms? Yeah. So you start out and you're like, okay, button, you know, on click and on item data bound and all this, and you get to a point you're like, I know how to build websites now, I can do this. And then your boss says to you, oh yeah, we need a streaming media server. We want to be able to stream video. And you go into the toolbox in Visual Studio, you're like, I can't see a control for that. And so you start looking up and you're like, oh man, what? And then, you know, the abstraction that ASP.NET Web Forms uses is, I think it was designed to sell web programming to Visual Basic developers. Because it's all about buttons and events and on-click and data binding and stuff. And what you actually need to understand is HTTP and HTML and requests and response and headers and statelessness. And so you spend all this time learning web forms and you get up to here and then you're like, and that day you're going to go home in a bad mood. You're upset. You're like, I learned all this stuff and it's useless and now I need to start again. And that's just not a nice way to work. There's another thing you want to avoid, which is this. This is a brick wall. You know, this is monads. This is, yeah, we'll teach you this, and then suddenly you're like, I don't understand. Like, first time I learned recursion, the person who explained it to me, I was like, I didn't get that. I didn't get that. I just do it again, do it again, do it again. And it's kind of like there's no way of getting from there to there. It's basically 2 different curves. Because once you've learned it, it's really then difficult to explain to people. Now, sometimes you get these. There are some concepts, you know, like recursion, like something like a Y Combinator, which they just click, and then you're like, I understand it now. One day I will understand monads, not today. But you want to try and avoid these if you can, because this is where somebody gets stuck. This is where they're working with your system, and suddenly they're like, I can't go any further. I can't do anything with it. Now, the thing that first sort of started me thinking about this whole idea of building these user experiences was, anybody use a thing called Castle Windsor, IOC container? So this is going back about 10 years now, when I first started working with containers in .NET. And I downloaded Castle, and I sort of plugged the code in, and I was following instructions from somebody's blog. And I pressed F5, and it came up with this error message. And I thought, didn't work. And then I looked, and I want you to look at what this error message actually says. Because what it says here is, looks like you forgot to register the HTTP module. Now, one, I like that. That's really friendly. It's not like, hey, you suck. It's like, hey, you forgot, We know you know. We're not going to admit that you have no idea what you are doing. You just forgot, obviously. And then it says, to fix this, and it gives you this little chunk of XML inside the exception message. And you think, this is cool. And you copy that, and you paste it into your config file, and you press refresh, and there it is. It works. The thing I really like, the person who wrote this error message, they could have just said, null reference exception. They could have just said invalid configuration, but they didn't. They were like, I know why people are going to get this error message, because there's this thing you have to do that is not obvious, but I know that it's going to happen to most people, because most people don't read the manual. They just download the code and they press F5 and they see what happens. So they're thinking, well, how can we make it so that when they press F5, that's when we give them the help? Now, anybody here work in a company where you have like a user experience team or UX designers? Now, there's this kind of idea in software that UX is someone else's problem, and we do backends and database and API design and stuff. I kind of want to challenge that thinking, because every piece of code, somebody is going to end up using it. If you build a database schema, somebody is going to have to retrieve data, to run a report, or draw some controls, build an API. If you build an API, somebody is going to build an application. If you build an application, somebody is going to be on support. There's going to be an engineer on call when you're on holiday and something goes wrong. So every time we create code, we're building these experiences for the people on our team, for customers, for other collaborators that we work with. And there's a lot of things that we can learn from front-end kind of user experience design and patterns and things about how to build better systems. So I'm going to walk you through a couple of examples now. Let's say you've just started work with a new team, and it's Monday morning, and you go into a new office, and they say, here's the coffee machine, and there's the fire exit, and right, let's get started. First thing you're going to do, you've got to get the website checked out and get it running locally. And you go, okay, I can do this. And you log into GitHub, and you see a repo called website, and you look in it, and it's empty. And you see another repo, it's called website 2, and you look in that one's empty as well. And you see, oh, website 2015, maybe that's it. And that one's empty as well. And then you find another website, but that's got some Perl scripts in it. And so eventually you turn to the person next to you in your new job, and you say, hey, I'm sorry to bother you, but where's the code for the website? And he says, oh, it's in GitHub. It's in a repository called Finance. And you're like, what? And they're like, yeah, the web developer worked for the finance team. And so you're like, okay, whatever. And you check the code out, and you press, you start building it, and it fails, because it can't find a bunch of DLLs that it needs. And so you say to your coworker, hey, I'm sorry to bother you again, but there's this DLL called mycompany.objects.dll. And he's like, oh, yeah, you'll need to, here, let me share my C drive, and you can copy all the files across. We've been there, we've done this. And then you get it up and run. Finally, you press go, and you're like, oh, man, it needs a database connection, and now I need to restore the SQL and all this kind of stuff. And if you're lucky, you keep bothering the person next to you all day, and eventually you kind of get the thing running. But if you're not lucky, you just end up with this, Somebody got paid to write this. Somebody went, yeah, I see what's gone wrong. Shall I help them? Nah. Unspecified error. We don't care. We can't be bothered anymore. This is just a really kind of bad experience. And so, most sort of good developers, they go through something like this, they're going to document it. They're going to write down all the steps they had to go through and all the DLLs that are missing and the process for the database. But that's the kind of documentation that goes stale really quickly. Like a week later, someone will have changed the DLL, and they won't know that you've written this wiki page. And so suddenly the wiki page won't be accurate anymore. So let's try the same thing again in a different company. You go in Monday morning, they say you've got to get the website running locally. And they say, by the way, the website is in GitHub. It's in a repository called Applejack. And you're like, okay, whatever. So you go into GitHub, and you find Applejack, and you clone the repo, and you press F5, and it says restoring NuGet packages. And you think, hang on, that's interesting. This company has their own NuGet server, where they've put all their DLLs, so you don't need friend's C drive. And it restores all these things, and then it comes up with a screen, and the screen says, hey, it looks like you don't have a database. Go into the repo that you just checked out, and you'll find a folder in there called SQL. That's the database scripts. So one, you've got this little dopamine rush. You're like, I solved the puzzle. I solved the problem. I'm doing this. I haven't had to ask anyone for help. I'm doing it on my own. You get it up and running, and you also, because you've got this kind of problem-solving thing going on, you're going to remember it. You've just learned that there's a database folder in the repo which has your schema definition. So in a couple of days' time, when you need to go and check how a particular table was created, you'll remember that there's this folder in the code base which is where everything comes from. You don't need to ask anybody. And so, it takes you a couple of hours, and then your coworker says, hey, do you want to come out and get some lunch? And you say, yeah, and as you're walking out to go and get a hamburger or something, you say to him, why is the repository called Applejack? And he says, oh, we just name all our repos after My Little Pony. And you're like, what? And he's like, yeah, we just needed names. They're code names. They don't matter, but it's important to have names. So we just had this big list of all the ponies, and every time you start a new project, you just pick a name from the list, and that's what we do. And it says, it sounds silly. You're like, really? This? But after a day or two, and this works really well. You have system monitoring. You get an email saying there's a problem with Applejack. You know which system's gone wrong. If you want to do metrics, work out which applications are, cranking up your Amazon or your Azure hosting bill, you're like, we spent $2,000 hosting Applejack last month. Maybe we should look at what's costing so much. We have this concept in software of bounded contexts, and the idea of breaking your organization down into domains. And names are a really easy way to kind of create that structure. We have Applejack, and this is everything in this system here. This is Applejack. And all of that, that's Brandy Snap. And all of that is Cherry Jubilee. And, the names, they sound silly for like a day, and then it doesn't matter. After that, it's working. Okay, do a little bit more history. This was my first computer. Well, this was kind of like my first computer. It was a 286. It ran MS-DOS off floppy disks. And when you switched it on, it would go kind of grrr, ding, 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 beep, and then it would go. And you'd go, hey, I got a computer. What can I do with it? And you go, hello. And it says bad command or file name. And you're like, I didn't mean to be bad. Maybe there's a menu, bad command or file name. Help, bad command or file. And, what you could do, which was kind of fun, is there's this song in English, If You're Happy and You Know It. So you can go, if you're happy and you know it, syntax error. This was the most fun thing you could do with DOS, but so it was this thing, it was literally a brick wall. You switch on this new expensive computer that you're going to start doing things with, and you can't do anything because all you get is A. And every time you try anything, it just says bad. It's a really, so you get the MS-DOS manual, which was this thick and really, really dull, and you start flipping through it. You're like, oh, dir is how I list my files, obviously. Now, at the same time, the other kind of computer that was very popular was the Apple Macintosh, the System 7 Mac. And when you switch that on, first you got this little picture of a little smiling computer. And then it would say, welcome to Macintosh. It's doing things. And it would click and grind for a couple of seconds. And then finally, once it's finished loading the operating system, it brings up this interactive desktop, which is full of things that you can click on. And you're like, okay, I have this mouse on the table. I move that. That's cool. It moves the thing on the screen. All right. And then you're like, okay, so file. That clearly I can do files with this new computer. And I can edit things, and I can view things. And there's, it creates this wonderful idea of affordances. It shows you what the system can do. So instead of just A and a manual, it's got these options. You can go in and start, picking things from it, seeing what's capable there. Now, something that I've seen a lot of people do, they're like, this is good. Our software has features. Let's give each feature a button. We'll put them on the screen. It'll be easy to use. You end up with this. See, you type your program in that little window in the middle, and that's how you do programming. You can't just go crazy and say, we've got all these features, let's put them all on the screen. Because that's almost as bad. You look at this, it's like the A thing. You don't know what to do first. You don't know what any of this stuff does. You don't know how to work with it. What we are trying to do here is to create systems which have a learning curve. Now, I'm going to show you my absolute favorite example of this, I think ever, is this.
Good morning. You have been in suspension for 50 days. In compliance with state and federal regulations, all testing candidates in the Aperture Science Extended Relaxation Center must be revived periodically for a mandatory physical and mental wellness exercise. You will hear a buzzer. When you hear the buzzer, look up at the ceiling. Good. You will hear a buzzer. When you hear the buzzer, look down at the floor. Good. This completes the gymnastic portion of your mandatory physical and mental wellness exercise. There is a framed painting on the wall. Please go stand in front of it. This is art. You will hear a buzzer. When you hear the buzzer, stare at the art. You should now feel mentally reinvigorated. If you suspect staring at art has not provided the required intellectual sustenance, reflect briefly on this classical music. Good. Now please return to your bed.
So that's the opening level from the game Portal 2. And what I love about that is that it's funny, it's engaging, and in the space of like a minute, it teaches you how to move, it teaches you how to interact with the environment, it teaches you with little hints that pop up which keys you can use. So it's the beginning of this sort of learning curve experience. Now, there's another example I'm going to show you. This is from Microsoft Edge, which is Microsoft's new standards-compliant kind of complete replacement for Internet Explorer. It's their new web browser platform. And as a developer, the first time you go and install Edge, you go in, and you right-click on the web page that you're doing some work on, and you're like, there's nothing here. Select all and print. I can't work with this. I'm a serious engineer. Where's all my tools? And so you go up to the three-dot menu here. You click on that, and you notice there are the developer tools. So a couple of things you'll notice. One is those are F12 developer tools. The fact you've just solved the puzzle, you're going to remember it. Nothing else has a shortcut key. F12 is developer tools. So you're like, okay, I've remembered that. And you switch it on, and then you get this thing that says inspect element and view source now appear in the context menu. Now, I love this because for 99% of people using a web browser, they don't need view source. This is when your dad or your mum phone you up and go, the internet's gone weird, I can see the code. And you're like, no, just close the window, don't worry about it. But for developers, it's this really nice experience because it's that quick. It's 10, 15 seconds. Edge has worked out that you're an engineer who's here to try and do some work. It's like, all right, we're going to switch on these tools for you because we know that you know what you're doing. This is fine. You've found the developer tools, we're going to switch it on. So let's start talking a little bit about things you can do in your own code to try and create these kind of patterns for the people working with your applications and your libraries. Now, I'm assuming that this being like, a .NET conference, you've all come across this idea of intelligent code completion. You type an object and you go dot and it says, look, we got all of these things here that are available. Console.foreground color equals, and then it's like, well, this is an enum, so we can actually show you right here the options that are available, yeah? It's pretty cool. It means you don't have to read the manual. You just dot, scroll, dot, scroll. And that's how you work out how to write your programs. And, we've all worked with this, but how many people have actually used this in their own code, their own class libraries and things, to create a better experience for the other people who are collaborating with it? Now, something that I realized a long time ago, I can't write connection strings. I've been a .NET developer for 15 years, and I cannot write connection strings because I cannot remember the syntax. I go new SQL connection, and this pops up, and I'm like, and at that point, I can't remember it. And I have to go and look on connectionstrings.com. So what I did is I made a little library called SQL.connect as one class with a static method, and I took the documentation, and I pasted it into the comment so that when I get stuck, it actually gives me there on the screen, just long enough, it gives me the syntax of a SQL Server connection string. And, this is actually really, really easy to do. If you're using something like Visual Studio, which has support for it, the code that sits behind this is very, very simple. You just embed some XML in your documentation, and that's it. It's a special comment. It's on the class. And if you're using an editor that supports it, like Visual Studio or Visual Studio Mac or Rider, this pops up. The exact point you get stuck pops up, helps you out for just a second, and as soon as you close the bracket, it goes away again. Now, I love that because there's no friction. You don't have to stop. You don't have to switch windows. There's no kind of Alt-Tab and look it up on a browser and all that kind of thing. And this stuff is easy if you know what your user is trying to do, because a lot of the time, someone who's using your class library, you have a pretty good idea what they're trying to accomplish there. But sometimes you don't know what the user is trying to do, and so you have to try and help them out by giving them, options, giving them a range of things they can pick from. So we have a pattern in user experience design called signposting, which is the idea of, that the user is at a particular point in your application, or they're trying to configure some code, something. Where can you go from here? What are the things that are available? Now, one of the kind of best implementations of this I've seen is when you're building HTTP APIs. There is a thing in REST called hypermedia as the engine of application state. Web pages are easy to use because they are full of links, and the links tell you where you can go. Click on a link, you get another page. If you don't like it, you go back, click another link, you get a different page. The web is a very discoverable system with if it's a good website, with very good signposting. And we can use those same kind of patterns in APIs that we create. And not only that, so I'm going to show you now, this is a project my team and I have been working on this year. And it started out as a REST API with hypermedia inside the resources. So you get back some JSON, and then in the JSON, we're using a thing called HAL, Hypermedia Application Language, to put links inside the JSON to tell you what else is available. And then we started building little tools for ourselves we could use to explore and debug the code. And then we thought, well, why don't we just publish the tools as part of the API documentation, and anybody can go in and do it. So this is a live system. It's not open source yet, but it will be. And basically, anybody who's got credentials can go onto this thing. They can switch between the live system and the sandbox system by just clicking on one of these links. And we have code running in the browser that will take the JSON and it will actually hyperlink it for you. So somebody who's trying to, that started working with our API and they just want to go in and play around with it and try some things, they don't have to write code. They don't have to, write programs or refer to documentation. They can literally just start exploring, playing around with it. And it started out with us just supporting, clicking and navigation and going from one resource to the next. And then we actually embedded some real hypermedia controls in it. So you can go into one of the resources, you can actually bring it up inside the browser, submit the operation from there directly. It all runs client-side, and you can test, patch, and post, and put, and delete methods as well. So it kind of eliminates the need. The documentation now is, we've kind of stripped it back down. If somebody needs to know what's the particular character set that a field supports, that's the kind of thing I think documentation is for, because that's almost like the engineering specification. But for just exploring the system and developing in your own mind an idea of how you can work with it and how you're going to implement your own solution, how you're going to build something on top of it, I love this idea of just putting things out in the open where people can explore them and play with them. So we've talked about collaborating with other developers, but there's another kind of really significant category of people who will be working with your code, and those are the people who support it. The on-call engineers, your operations team. If you're shipping software to third parties, they'll have an operations team who's running it. And so we're going to talk in the last part of the talk here about logging and about monitoring. So there's two scenarios here. One of them is you go to work and the phone rings and someone says, there is a problem with your system. And you say, okay, let me make a note and call you back. And you take their number and you put the phone down and you're like, problem with the system, and the phone rings again. And you say, hello, and they say, yeah, the problem with the system. And you're, which system? They say, the internet system, it doesn't work. And you start trying to capture some details, and this goes on for a couple of calls, and eventually you get someone on the phone who's like, do you want me to send you a screenshot? And you're like, yes, thank you, please send me a screenshot. And they send you this. And you're like, okay, it's a request timed out. And you're thinking, so there's 60,000 lines of code in production, probably about 5,000 HTTP requests in there, and your boss is like, how long to fix the problem? You're like, well, there's 5,000 HTTP calls, and I can probably check one every 20 minutes, so, I don't know, 6 weeks? And your boss is like, what do you mean? You're like, I don't know, I have nothing to go on. All I know is that request timed out. I don't know where the problem came from. I don't know which system is failing. I don't know what caused it. I don't know if there's anything weird going on with the network. I don't know if it's one of our API integrations or something. You don't know. And so you're kind of upset and unhappy and frustrated. Your boss is upset and unhappy, frustrated. Your customers are all bringing you up and they're shouting and they don't like it. It's bad, this is not good. Now, another scenario, you get into work, and before the phone has even rung, you have this thing on the wall. You have a big flat screen TV, which is showing you a monitoring status of all of your production systems. And normally it's green. And this morning, when you get in, there's 3 things on it are red. And you can see, okay, so what's down here? The main website, the intranet, and the content delivery network. So immediately, nobody else has noticed this yet. The phone hasn't started ringing. You haven't got the angry people on Twitter. And you're like, okay, so I already know that if the CDN goes down, then the intranet and the main website are going to fail. So let's immediately start looking at the CDN. And you go in, you start looking, and you're like, somebody's revoked one of the certificates, or certificate's expired, or something's happened. And, before customers have even noticed, you can often identify these issues, jump in, diagnose them, keep everybody up to date, everyone's happy. Now, this is actually my office in London. And the really cool thing that we didn't realize, we wanted this for us. We wanted this on the wall so that the engineers on my team could see what was going on. But the thing we've noticed that's really cool, if someone comes over to bother you, they're like, have you, made your menu choices for our Christmas lunch and, this kind of thing. If they see red on the screen, they'll go away because they know that something's broken and you're working to fix it. And sometimes they'll come over to hassle you about something. They'll see red and they'll be like, is everything okay? Can I get you some coffee, or does anyone need me to go and get sandwiches for lunch? And that's awesome, And we had no idea when we put this system in that people would pick up on it. But it really does create the sense of we're actually all on this team and we're all working together to solve this problem and everyone is trying to help out. And it's just a completely different way of dealing with outages and exceptions and things that go wrong in production. It's just a much better experience. Now, it's a little bit like the feature dashboards and the Visual Studio thing we talked about earlier. The problem with monitoring is getting a balance right, because you don't want just a big red light, and if the system goes down, the light goes red, because that doesn't give you anything to go on. But also, you don't want something that looks like this, because there are too many systems, and at any given point, something is probably not quite right. They used to say when NASA was flying the Saturn V, they said we got a 99.9% success rate in a machine with 6 million moving parts, which means we'll have 6,000 failures on every successful flight. Any sufficiently complicated engineering system is going to have something in it at any point that right now is not working properly. There's a particular cluster, node in one of your clusters that's just underperforming. There's one database that's running a reindex, so it's going a bit slowly. You need to kind of strike a balance. You want something more like this, which is just, this is your car, and it's like, this is the brakes. If this light comes on, go to the garage, say there's a problem with the brakes. This is the fuel. If this comes on, put fuel in. It breaks it down to kind of a manageable number, about half a dozen different systems that will tell you where do you start looking and what's the next thing you need to do about it. Now, one of the things that I always loved about the older Star Trek series is on the Starship Enterprise, they have this engine. And the engine is there in the middle of the room, and people look at it. It's transparent, It takes the kind of the thing which would normally be hidden away behind a panel somewhere, and the designers of the show are like, no, let's bring it right out and make it part of the set. Make it something that everyone can see. We'll use it as part of the kind of narrative. And you can do the same thing with your own applications. You can build dashboards. Take the covers off, and say, all right, people who know what they're doing, they can actually get in and look at what is running in our system right now. Now, the API Explorer thing I showed you, the backend for that is running on a system called Nancy, which is a framework for building HTTP APIs in .NET. And one of the really nice things that Nancy gives you is it has this dashboard built into it. So on a production system, you set a config value for it, and then you can go in and you just put _Nancy on the end of your URI. And it gives you this kind of secret dashboard. You punch in your authentication password, And what you're looking at now is a live view onto the running state of an application that is in production. This is live, you know. This isn't you've copied it locally, you're running it in Visual Studio. This is what's actually coming out of the state of that application at this moment. So you can see all of the configuration, all the components, all the services that have been registered. All this stuff is just there for you to go in and look at. And it's really, really valuable when you're trying to go in and diagnose a problem. You can see the routes which have been compiled into the application, because you know what you told it to do, but maybe it did something different. You know, maybe there's some case sensitivity problem that you hadn't realized. Maybe one of the code blocks is being bypassed. You can even go in, this is really smart, you can switch on request tracing. You can say, I want you, for the next 30 seconds, to log every single request that comes into our production system. Then you can go into one of those requests and you can see every single detail of it. This isn't like Elma or something where it has to crash before you can see it. You can do this for successful requests. So you can see all the headers, you can see the negotiation, authentication, all the schemes. As soon as you got what you need, you switch it off again. It's a really, really powerful approach. And since we started working with this, we're now constantly thinking, building a system, how do you expose the state of that application to the people who are working with it? What are they going to need to know? What's the interesting details about what our application is doing right now? And that's one side of the puzzle. You want to know what's happening now. The other side of the puzzle is logging. What was it doing before? Now, you go into work, there's a red thing up on the wall, one of the squares on your monitoring dashboard has gone red, and you're like, what's the problem? And someone says, oh yeah, it's the database, the CPU's at 100%. That's one data point, Now, that doesn't help. You're like, well, why? How did it get there? What happened? Because there are 3 different ways that I've seen a database server end up at 100% CPU. One of them looks like this. It just gets busier and busier and busier and busier, slowly, over a long period of time, and eventually you hit 100% and suddenly things start failing. Another one looks like this. This is what we found on one system where we're running a nightly backup. And every day the database is growing, and so every night the backup gets a bit heavier, a bit more intensive, until suddenly one night the backup completely maxes out the capacity of the box, and it becomes unreachable. We had a downtime at 2 a.m., like what's going on? Okay, we have a problem with the way we're managing our backups. And the other thing, which I've seen a lot more often than either of the others, is everything is fine, and then you click deploy to production, and this happens. Bang. So 3 very, very different scenarios. Just knowing that you got 100% CPU, that doesn't help. You can't use that information. You want to understand. And the other thing you need to understand, how long did this take to happen? Was this since this morning, 10 o'clock, 11 o'clock, 12 o'clock? Or is this January, February, March, Because they're very different scenarios. But without this degree of visibility, if you don't know what you were doing last week, how do you know if what's happening today is normal? Because nobody else in the world is running your applications on your infrastructure. The only baseline for comparison you have when something's going wrong is what was happening when nothing was going wrong. So this is a live snapshot of one of our production database systems, and we're based in the UK. Most of our customers are based in the UK. This is activity for 24 hours. And you can actually see here, you start on the left, you got 8 p.m., 10 p.m., you got the big spike up at 10 o'clock when we flush a bunch of things, rebuild some indexes. You can see everyone logging on at 10 o'clock in the morning. They work for a couple of hours, they come back from lunch, and then at 6 p.m. everybody goes home. This is a typical day for us. And if we see a problem, first thing we do is we pull up this tool, which is from Redgate. It's a thing called SQL Monitor. And we say, is today different? Does today look different to yesterday? What was last Tuesday, Tuesday before that like? And being able to just plot one time period against another on this thing is an incredibly powerful diagnostic tool for working out, do we have a problem? How quickly did it get here? Was it a deployment? Is it a capacity issue? But it's also the kind of thing, once you have this visibility, you can turn around to your boss and say, we're going to need a bigger database server in probably the 5th of April, 2018. And they're like, how do you know? And you're like, see this graph? Yeah, it's going to hit 100% there. Maybe a couple of days either side. Put it in the budget. We're going to need it. We don't want this to be a surprise. And that's a much happier experience for everyone. They hate it when you turn around and go, can we have more money for more hardware or more Amazon virtual infrastructure? It's much nicer to be able to plan and predict that kind of investment. Okay, Last thing we're going to talk about, we've talked about systems logging. We talked about, network, CPU, that kind of visibility. We're going to talk about application logging. What can you do in your code to make it easier for other people to work out what was going on? Now, there are 5 levels of logging that most kind of .NET applications use. There's this sort of precedent that's been established in our platform. We talk about fatal, errors, warnings, info, and debug. If you are going to have lots of people logging to the same infrastructure, so first thing about logging, get the logs off the system that's doing the work. Get them off the C drive. Do not switch on logging, because what will happen is you'll never look at the logs, and then in 2 weeks the server will fail, and you'll be like, what happened to the server? You're like, oh, the C drive's full. What's it full of? Log files. How do you know? Well, actually, we couldn't boot it, so we had to take the hard drive out. And then we put it in something else, we discovered it's full of log files. This is really, really bad. What you want to do, you want to get the log files off and you want to put them somewhere centralized. You can build your own. There are systems, Graphite, Splunk, Logstash. There's all kinds of ones you can run your own. There are software as a service providers. There's Graylog, there's Logentries, there's Logit. It's one of the best things that you can invest in if you've got multiple teams, multiple applications. But as soon as you've got that, you're going to realize that all your teams are doing something different. You got one team who log info every 10 seconds forever. You got another team who use fatal to report that a user forgot their password. You need to establish some consistency between the different levels so that the aggregated logs are meaningful. So this is kind of the way that I think we should do this. To me, fatal means that it is completely unresponsive. Multiple users are affected, it's immediate attention. Now, the interesting thing about this, there are probably applications in your system which cannot cause a fatal exception because the application is not that important, If you have a system that runs like a seating plan for a shareholders' dinner and that fails in the middle of the night, nobody's planning a dinner in the middle of the night. It doesn't matter. It can wait until you get back to work the next day, That's something, you put it on a list. You don't wake someone up for it. To me, errors and warnings they're things that will happen. You got a timeout calling a remote API, or there was a database deadlock transaction victim, these kinds of things. The distinction I find, if it's an error, somebody noticed, but they can probably try again. Press F5, they'll have another go. Maybe next time it will succeed. A warning is like, we tried to get some, say, currency exchange rates from an API, timed out. It's all right, we're going to fall back. We'll use the cached version. That's okay for 10 minutes, an hour, 1 hour. You don't want to be running on foreign exchange prices that are a month out of date, or you might be losing money. Think about these. The individual messages aren't useful. What you want to watch out for is volume. These are like somebody on public transport who's going to a costume party, so they're dressed up. You see one person on the metro, and they're wearing like a pirate costume. It's like, all right, well, they're going to a party. If this happens, you're like, this is interesting. Something unusual is happening here. We should probably try and find out what this is. To me, info is everything is fine. It's the town crier going 2 o'clock and all is well. The main reason why we use info messages, you go home for a big public holiday weekend, so everybody's out of the office for 4 days. You come back on Tuesday and there's nothing in the logs. They're empty, completely empty. Now, 2 things. 1, you had a perfect weekend. Nothing failed. No errors, no warnings. 2, your logging infrastructure failed on Thursday night. Which one do you think is more likely? So you go and look, if you've just got like an info message every 10 minutes, recycling application cache, shutting down a server, bringing up another server, elastic scaling, load balancing. Info is just, nothing's wrong. We're just letting you know what's happening here. And you don't want thousands of these. You want maybe, an info message every few minutes, just to kind of give you a heartbeat, a pulse of what the system's doing. And finally, there's debug. Now, I recommend if there's one thing that you change about how you write software after coming to this conference, the next time you go console.writeline, stop, install log4net or nlog or serilog, and start using log.debug instead of console.writeline. All of the stuff that is valuable to you when you are building your applications, it might be valuable to somebody else later if they are trying to work with your code. They're going to want to see the things which help you make your decisions. When you go to production, you just switch it off. The thing about this is you can use debug logging to log everything. All the state, all the interesting things, entering methods, method timing, method results, recursion, callbacks, all the little tiny details that only matter when you're trying to debug something complicated. And as I said, this is going to create a lot of information. So when you go to production, switch it off. In every good logging provider for .NET, it's one XML configuration flag. Localhost, developer mode, log everything. When you go to production, switch off debug. Just don't do it. Because one day, you're going to hit a problem that doesn't happen on staging, and it doesn't happen locally. It only happens on production at 3 o'clock in the morning, and the only way you're going to be able to do it, to fix it, is to turn debug logging back on for that system. Because at 3 o'clock in the morning, you're going to be really, really happy that the person who built it put all these hooks in that you could use. You could actually, all the stuff about logging, all the confusion, everything is just because I think they gave them all the wrong names. It shouldn't be fatal error warn info debug. What they should have called it is log.wake me up at 4 a.m. on a Sunday. When you write that in your code, you're thinking, do I? No, I don't want to get woken up. This isn't important enough. Error should be called apologize to the user and raise a ticket. Warn should be called make a note in case this happens again. Info should be called log.everything is fine, just checking in. And log.debug should be called log.fill my C drive with stack traces. So a guy called Daniel Obrero wrote this brilliant blog post where he came up with this idea, which I've adapted a little bit. So credit him if you're going to share this. So, we've talked there about application development. We've talked about signposting, IntelliSense, user experience design. I just want to recap what I think are these rules for creating happy code. So first rule, names. Remember Applejack, remember My Little Pony. Or if you don't like My Little Pony, different kinds of single malt whiskey, or different cities, or anything. Come up with a way of naming things and use the names, because names are brilliant, You want to find out what's going on with Applejack? Type Applejack into the wiki, you get the project documentation. Applejack into GitHub, Applejack into your logging server. You can use Applejack on, we even have systems where they send email from applejack@spotlight.com saying, hey, we had a problem, or hey, everything's fine, or hey, you thought you might want to know about this. It's a really, really nice way of getting everyone to understand this idea of bounded contexts and the boundaries, the interfaces between them. Second rule, learning curves, Make them smooth. They can be steep. You might want someone to go and cram your system for 12 hours and they come away absolutely brilliant. Maybe you just want to build a very, very shallow, gentle learning curve because most people aren't going to need to get their hands dirty with what you're doing. Watch out for the localized peaks. Don't build ASP.NET web forms and try and watch out for that whole monads jump thing. Think of the points where someone is going to get stuck. And part of the way you do that is by thinking about failure points, error messages. There's a point in your system where every new developer who works on it gets stuck. Think, maybe we could be more helpful here. Maybe we could put the packages on a NuGet server. Maybe we could put help in the error message. Maybe there's something we can do here. Signposting. Think about what your application offers. If you're doing something like a configuration system, maybe you could use a fluent interface. So you type dot, and it gives you a whole bunch of options. Database, dot, connect, dot, with encryption, that looks useful. Dot, using credentials, that looks useful. Dot, timeout. There's all of these things you can do that will help you kind of explain to people as they go along, what are the capabilities of the system that we've built, and how can you use it effectively? Transparency. Take the covers off, expose dashboards, expose logs, expose metrics, capture and share all of this information that was useful to you when you were designing the system, because it's going to be useful to somebody else. And that somebody else might be you in a year's time. You might be coming back to your own code and going, I can't remember how this worked, but that's all right. You left clues for yourself because you were smart. And you log into the dashboard, there's the state. That's what everything's doing. And the golden rule of, I think, all development, the golden rule of happy code, remember that you're creating user experiences. Whatever it is that you're doing, if you're building a database, somebody is your user. They are going to be working with your data schema. If you're creating APIs, somebody is going to be developing the application. If you're creating class libraries, you're creating frameworks, somebody is going to be working with them. And it's up to you whether that person is going to go home grumpy and tired and upset, or whether they're going to go home going, that was cool. We did good stuff today. I want to go back to work tomorrow. Because those are the kind of happy people who build really good software products. Thank you very much.
вопросы? Есть какие-нибудь вопросы к Дилану?
Поднимайте руки выше, пожалуйста, и мы к вам подойдем.
Все было настолько понятно? Dylan, everything was clear. The audience have no questions.
Total enlightenment. Everybody we understand now. So, do we have the discussion areas?
Yes, we have discussion areas.
Okay, so I'm going to go outside. I'll be at discussion point 1, where we've got a flip chart and whiteboards. So if nobody comes, I'm just going to draw My Little Pony pictures. If anyone has any questions, anything they want to chat about, please come over, find me over there. We'll have a conversation. Thank you. Спасибо.
Thank you.